Alright, welcome back to my YouTube channel. This is the continuation of the last video, which is the expansion of a function in a series of orthonormal eigenfunctions or orthonormal functions. So we have a question: f of s is equals to x. So we are asked to expand it in this series of orthonormal eigenfunctions. So to do this, you will need to get your orthonormal eigenfunctions, and if you check the video on orthonormal eigenfunction, you will see that this problem was the example that was used there. So which means that we've gotten the orthonormal eigenfunction from the previous video, so you can check it out and see the step on how to solve it. So if you are given this to do, maybe probably in your exam, you will need to solve you will need to solve to how you get your orthonormal eigenfunction. So I recommend that video. Go and watch it. You see the total step on how to solve this orthonormal, how to get the orthonormal function. So let's start. So the orthonormal eigenfunction are what? The orthonormal eigenfunctions is function is y of n equals root 2 sine n pi x. Yeah, so for n equals 1, 2, 3. So this is the orthonormal eigenfunction. So now that we know our orthonormal eigenfunction, so we want to expand f of x in this series. So we know from the previous video that to do that, you have to define f of x as summation n equals 1 to infinity cn and then phi of n of x. So in this case, what is your f of x? Your f of x is x, and then your phi of n has a meaning too. Your phi of n is root 2 sine n pi x. Okay, so let's solve for cn. So to solve for cn, you remember from the remember that you multiply. The first step is to multiply both sides by what? By r of x phi of m. So remember that the r of x is the weight function and phi of m is just picking one function from the set of orthonormal system. Let's go up. What is r of x? So r of x is the coefficient of this lambda y, which is actually 1 here. So you can just say r of x is equal to 1, and then phi of x is equals to root 2 sine m pi x. So that will give you root 2 sine m pi x. So this is the function you are going to use to multiply both sides. So that will give us root 2 sine m pi x equals summation n equals 1 to infinity cn root 2 sine n pi x, then root 2 sine m pi x. So n equals 1 to infinity cn. If root 2 times root 2, you can just write root 2 squared. It doesn't really matter. Then you have sine n pi x sine m pi x. So after multiplying both sides by the r of x and phi of m, the next thing is to integrate now. So you integrate with respect to x from where? From 0 to 1. So we don't use a to b here because the given interval here is 0 to 1. I picked it from the initial conditions. So 0 and 1. So that is the interval at which s is defined. So to solve this now, you just add the integral from 0 to 1 s root 2 sine m pi x dx equals summation n equals 1 to infinity integral from 0 to 1 cn root 2 squared sine n pi x sine m pi x dx. Okay, so just rewrite this sine m pi x dx. Okay, so this is the same thing, just like what we did there. This is a constant, you can bring it out. Don't bring out the root 2, just leave it inside. Then just focus on this, then sine m pi x dx. So that this integral will give us something. This integral has a meaning. So you just say that since this set root 2 sine m pi x is what is an orthonormal, then or is an orthonormal system. Okay, this is okay, it's an orthonormal system. Then the integral from 0 to 1 root 2 squared sine m pi x sine m pi x ds is equal to 0 when m is not equals to n, then 1 when m is equal to n. So that is why you don't have to, if you bring out this as a constant too, then at this point where you are saying 0 and 1, you will be wrong. So this is your, the formula is bn sine bn phi of n phi of n. So the bm is a constant, so that is why I left it is bm squared or bn, anyone. So this is a constant, so you have to leave it inside. If you take it outside and then you do this, you will miss it. So the only thing you should take out here is the cn. So every other thing you just have to say they are orthonormal system, which is true, and they form a set of orthonormal system, and it is 0 when m is not equals to n, and it is 1 when n is equals to n. So what do we do? So coming back to what we're solving, so you write this again, sine m pi x dx. So this will give you sine m times 1, because the whole of this will give you 0 when m is not equals to n, and it is just at a point m is equal to n. So at that point your integral gives 1. So this is just cn. So therefore the cm is actually equals to 0 to 1 s root 2 sine m pi x dx. So if you compare it with this formula, cm equals integral from a to b f of x r of x then phi of m ds, you will see that if you compare with this formula, you see that that is exactly what we've gotten. So your x is the f of x, although your a and b is from 0 to 1 now, and then this part is your phi of m, and then the r of s is 1. So it is very, very correct. So when you mimic the proof, when you get to this point, it's always better you compare it with this formula to see if everything is in place. So the next thing to do is to solve that integral. But to solve that integral, let's consider, okay, let's bring out this root 2, because it's a constant. Then you have s sine m pi x dx. So to solve that integral, let's consider this integral. Consider integral of s sine m pi x dx. So looking at this integral, to solve it, you will need integration by parts. So you can just say using integration by parts, what is the formula? Integral of u dv equals u v minus v du. This is the formula for integration by parts. So let's define our u. you can just say let u be equals to x and let the v be equals to sine m pi x dx. So if you look at the integration by part formula, we will need our u, v, then du. Now we have u, we need du. So to get du, differentiate this, you have du dx is equal to 1. If you cross multiply, du is equals to ds. And at this point, if to get v, you integrate both sides. So you have sine m pi x ds. So integral of this will give you minus cos m pi this is x, sorry, m pi x over m pi. So let's substitute these two values into the integral. We have s sine m pi x dx now is equal to, we have u is x, then we have v is, this is v, minus cos m pi x over m pi, then minus integral, you write your v again, but the formula say v, this is v, minus cos m pi x over m pi, then what else, then we have du is 1, sorry, du is ds, so you can just say ds here. So solving this, just go down. So solving this, we get minus s cos m pi x over m pi plus integral cos m pi x over m pi dx, and then this will give you minus s cos m pi x over m pi plus 1 over m pi integral of cos m pi x dx. So if you solve that, so if you integrate this, you get sine m pi x over m pi. You can just add plus c. So at the end of the day, we get minus cos m pi x over m pi plus sine m pi x over m squared pi squared plus c. So therefore this integral is this. So let's go back to where we were. So this is where we started from. So we are going to write this expression again, but this integral, we know what it is, so we just need to add the limit to it. So let's rewrite that part. So we have cm is equal to root 2 integral of s sine m pi x from 0 to 1 ds. So cm now is equal to root 2 cm is equal to root 2, then this integral has been solved to be minus cos m pi x over m pi plus sine m pi x over m squared n squared. Yeah, that is what we got. So now just add this limit, that is from 0 to 1. Now we have root 2 minus s cos m pi x over m pi, this is x, plus sine m pi x over m squared pi squared. So we had the limits now. So first we put 1, so we get minus 1 cos m pi over m pi plus sine m pi over m squared n squared minus you put 0 here, everything becomes 0, so you get 0, and here you get sine 0 over n squared, which is actually still 0. So from here we get root 2 minus 1 cos n pi over n pi, then sine of n pi is equal to 0. Sine pi is 0, so when you say n pi, it is still 0. So n can be 1, can be 2. If you verify your calculator, you get 0. So this is plus 0. This other one too is 0. So everything there is 0. So we just have root 2 minus 1 cos n pi over n pi. This is what we get. So let's do some analysis, and it is very, very important to understand this part. Now let's consider this. Let's see the behavior of this cos pi. And what do we mean by looking at the behavior? We want to see what this function gives for giving values of m. So let's say, for example, if m is equal to 1, you get cos pi. Cos pi will give you minus 1. If m is 2, you get cos 2 pi. This will give you 1. Let's do it up to 4. If m is 3, you get cos 3 pi, which will give you minus 1. And if m is 4, you get cos 4 pi, which will give you 1. So what do we observe? We see that when m is odd, 1, 3, if you continue to 5, you always get minus 1. And when m is even, 2, 4, 6, you will get 1. So we can just say that cos m pi is equal to minus 1 raised to the power of m. This is the same way this is behaving for these values of m. That is how this minus 1 raised to the power of m will also behave. So look at it. When m, for this guy too, for this minus 1 raised to the power of m, if m equals 1, minus 1 becomes minus 1 raised to the power of 1 become minus 1. If m equals 2, minus 1 raised to the power of 2 will give you 1, and so on and so forth. You see that it has the same behavior. So we, instead of writing this cos, we write this. So let's come back to where we are. So we have this guy is equals to the root of minus 1 cos m pi over n pi. So this is where we were. So this will now give you minus 1. Then this cos m pi is now minus 1 raised to the power of n divided by n pi. But you can see that there is another minus 1 outside. So this minus 1 can times this minus 1 using law of indices, and that will give you minus 1 raised to the power of n plus 1 and divided by n pi. So that is your Cn. That is your Cn, and I think we are done. So let's come back to the general formula. F of x, which is x now, is equals to summation n equals 1 to infinity Cn phi of n. So we've gotten what C is. C is root 2 minus 1 n. Okay, now we can use n, it doesn't matter, over n pi. Then what is phi of n is the orthogonal function, which is root 2 sine n pi x. So if you use this to times this, like root 2 times root 2, you get 2. That 2 can come out of this summation. So you have this, then minus 1 over n plus 1 over n pi, then sine n pi x. So this is f of x. This is x now. So x has been expanded in a series of an orthogonal function. Thank you very much. See you in the next video. If you haven't subscribed, make sure you subscribe. Thank you.